In this video, we explore a beautiful algebraic puzzle involving two integers m and n. These numbers satisfy two symmetric conditions, m squared equals n plus 2 and n squared equals m plus 2. Using only algebraic identities and logical deduction, we will evaluate the expression 4 times n minus m cubed minus n cubed. Stay with me until the end. The conclusion is surprisingly elegant. We are given two integers m and n such that m squared equals n plus 2 and n squared equals m plus 2 and m is not equal to n. Our goal is to compute the expression 4 times n minus m cubed minus n cubed. First, let's note m squared equals n plus 2 and n squared equals m plus 2, respectively as equalities 1 and 2. Now we begin by rewriting the expression 4 times n minus m cubed minus n cubed is equal to 4 times n minus m cubed plus n cubed. Next, we recognize that the sum m cubed plus n cubed can be factored using the identity m cubed plus n cubed equals m plus n all times m squared plus n squared minus m times n. Thus, the expression 4 times n minus m cubed minus n cubed become equal to 4 times n minus m plus n all times m squared plus n squared minus m times n. We label this as equality number 3. Now, to evaluate our main expression, we must determine the values of m times n and m plus n and m squared plus n squared. We start by subtracting equality number 2 from equality number 1, so we get m squared minus n squared equal to n plus 2 minus m plus 2. The right-hand side simplifies to n minus m, and the left-hand side factors as m plus n all times m minus n. Thus, we have m plus n all times m minus n equal to n minus m, which implies that m plus n all times m minus n is equal to negative m minus n. Since m is not equal to n, we can divide by m minus n to find that m plus n equals negative 1. Next, we add equalities 1 and 2 to find that m squared plus n squared equals m plus n plus 4. Replacing m plus n with negative 1 gives m squared plus n squared equals negative 1 plus 4. Therefore, m squared plus n squared is equal to 3. Now we determine m times n. Using the identity m plus n all squared equals m squared plus n squared plus 2 times n, we substitute the known values to get negative 1 squared equals 3 plus 2 times m times n. Thus, m times n equals negative 1. Now we return to the expression 4 times n minus m plus n all times m squared plus n squared minus m times n to find that it equals 4 times negative 1 minus negative 1 times 3 minus negative 1 by substituting m times n and m plus n and m squared plus n squared by their respective values, which are negative 1 and 3. This expression simplifies to negative 4 plus 4, which equals 0. Now, since equality number 3 affirms that 4 times n minus m cubed minus n cubed is equal to 4 times n minus m plus n all times m squared plus n squared minus m times n, we can deduce that our main expression 4 times n minus m cubed minus n cubed is equal to 0. Through algebraic manipulation, clever use of identities, and symmetry in the given equations, we have shown that the expression 4 times n minus m cubed minus n cubed is equal to 0. If you enjoyed this breakdown, don't forget to like the video, share it with other students who may find it useful, subscribe to the channel, and activate the notification bell so you never miss upcoming lessons. Have a great day and keep learning.